Alright, we're recording. Mean, median, and mode comparisons. You're going to be given a list of numbers and data. In this case, it's numbers of calls received during 20 randomly chosen 15-minute time intervals at a customer support service center. And we have 1, 4, 6, 6, 8, 9, 11, 12, 12, 12, 13, 13, 13, 14, 16, 17, 18, 19, 22, and 24. So there's 20 randomly chosen 15-minute time intervals, and they were recording the number of calls received during those 15-minute time intervals. You're going to be asked a number of questions that test your understanding of mean, median, and mode. The first of these is over here. So I copied these out of Alex, and you can see them. What do we have? That was weird. I don't know what just popped up a second ago. Which measures of central tendency do not exist for this data set? Choose all that apply. Okay. Mean. For any data set, we will always have a mean. What's the definition of mean? It's the average, right? And the average is something we can always find. Let me get a big pen. Average is the sum of the x's divided by the sample size. And here, clearly, we can get an average by adding up all those and dividing by 20. So do we have a mean? Yes, we do. Do we have a median? The median is the middle number. And even though we have 20 randomly chosen pieces of data here, so we actually have two middle numbers when you think about it. We have 12 and 13, both are the middle numbers, because we have number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 are both the middle numbers here. Do we have a median? Yes, we do, because what do we do when we have two middle numbers? When we have an even sample size, we take the average of the two middle numbers, which in this case is 12.5. So we do have a median. Do we have a mode? Mode is the most frequently occurring number. And in this case, we actually have two modes. This thing is bimodal. We have these, and we have also these. So each one occurs 3 times. So they are both the mode. So just because there's more than one mode doesn't mean we don't have a mode. The only time we don't have a mode is when we have a uniform distribution where all the numbers are in their equal number of times. So if all the numbers occurred 1 time or 2 times or 3 times, that would be a uniform distribution and it would not be a mode. Okay, having said that, the answer to this is... Let me get green pen. I like green. Is none of these. Okay. Suppose that the measurement 24, which is the largest measurement, was replaced by a 47. So what they're saying here is nix 24 and put in 47. How would that affect the mean, median, and mode? Which measures of central tendency would be affected by that change? So I'm going to go, which ones would be affected? Would the mean be affected? Absolutely. If you change one of the numbers, isn't it? I do not know. Okay. If you change one of the numbers, isn't it true you change the sum of the numbers? So yeah, this one would undergo a change. The mean would change. What about the median? If we change the highest number, will the middle numbers change? No, they will not. What about the mode? If we change the highest number, will the most frequently occurring number or numbers change? Not unless the highest number is the most frequently occurring. And it is not, so the mode, no. So right here, we check off the mean. Alright, suppose that, starting with the original data set, the largest measurements were removed. Which measures of central tendency would be changed from those of the original data set. Choose all that apply. So we're going to take out the largest measurement. So it's not that we're replacing it with a 47 anymore. We are, in fact, taking it out altogether. So let me do that. And it's gone. So now how many numbers do we have in the set? We have 19. And if we have 19, then the middle number is this 12 here, because there's 9 to either side of it. So the median is no longer 12.5, it is 12. So the median undergoes a change. So median. Oh, I don't know why I did that. So the median changes. Does the mean change? Yes, every time. Anytime we change any element of the data set, the mean will normally change, unless for some reason we are taking out a number that is equal to the mean. For example, on the last one, if before we changed it, if there was a number in there that was 12.5 and the average is 12.5, removing 12.5 would not affect the average. It would still be the same average as before, because we are taking out something that is equal to the mean. And I could actually do a proof of that, but I hope it's intuitively obvious. Okay, so if we take out any one of these numbers, if that number is not equal to the mean, then the mean is changed. Where's my little pen here? It's so hard to see sometimes. So the mean changes. Does the mode change? Does the most frequently occurring number change? Stop it. I do not want... Yes, go ahead. Change it. Okay, I hope that's better. I don't know what that was all about. Okay, the mode. Would the mode change? The most frequently occurring number would not change, because we still have 3 of those guys. Let me use my highlighter so you can see what I'm pointing at. We still have 3 of these guys. We still have 13, or a bunch of those guys, so we're still good. Okay? So the answer is just these 2. That one and that one. So you check off those. Lastly, which of the following best describes the distribution of the original data? Now, they were very nice to you guys, and they organized this data up here into this histogram down here. And because it's organized into a histogram, we can readily see that it's roughly symmetric. We can't say it's exactly symmetric, because we have classes here, and the classes organize the data, but in organizing it into classes, we lose some of the precision and that we observe when we actually see the actual numbers. So if we had a class width of 1, we would see that it's not exactly symmetric, it's roughly symmetric. When you have a positive skew, let me do these real quick. For a positive skew, let's do this. Positive skew means the tail is to the right. It's stretched out on the right side. Okay? Negative skew. Well, negative skew is when it's more over here. There's more on the left. Okay? The skew is always in the direction of the tail, not in the location of most of the data. So just because most of the data here is on the left, no, it's skewed to in the positive direction. And because most of the data is on the right here, it's skewed in the negative. And why that is actually because of what you're talking about. When you're talking about a skew, in here the middle number is going to be somewhere in there. And because we have this stretch, the mean is going to be to the right of the middle number. So this is the median, and the mean will be somewhere to the right, which is why it's a positive skew. In here you have the middle number. It'll be close to the hump. Okay? So that's the median. But because these data over here pull the mean, well, I don't know what just happened. Because the data on the left, this data over here, pulls the mean away from the center, the mean will be to the left of the median, which is why it's negatively skewed or left skewed. This is right skewed. So it's kind of counterintuitive. You don't look at the hump, you look at the tail. And I think that's it. I hope this is helpful to you. and we're going to stop the video there.